here's a few news articles. This is the UCSF, a UCSF physician who we have a very close relationship with UCSF. Quite a few students have worked there. They take a lot of our students to work in security and tech there. And, you know, he says the same thing I've observed from the outside. By shutting down San Francisco very quickly and by doing what we're told and staying home, we've made it so that it's not a madhouse in the ICU. I mean, he has a lot of sick people to treat, but it's not like heartbreaking and horrible and insane like apparently it is in New York and it was in Italy. It's good to hear from the inside. So Bolinas is going to test the entire population of the city. And that'll be the University of California, San Francisco doing it. So this is the kind of thing that we need to understand more about what's happening and find out how many people really have it, and perhaps even more information about who might be immune and such. So anyway, hopefully that will give us some valuable information. It does seem like we can't really open up any place until we have a lot more tests, but they're going to do it anyway. Although not here, I think. So this is one of these madnesses. I heard the interest rate fell below zero a while ago. Now the price of oil futures has fallen below zero, which is a kind of artificial number, meaning that it's more bothered to actually physically move the oil than it's worth to sell it right now for a certain date. The oil futures for the month after that are not below zero. So this is sort of an artificial number, but it does indicate a ridiculous crash in the price of oil, driven both by a large supply from the Middle East and an incredibly small demand because everybody's on lockdown and apparently nobody's driving around. So Lyft stock is crashing. Uber is not, which I had not anticipated, but Uber diversified their portfolio. Uber has Uber Eats, and Uber Eats is giving them some business. Lyft does not have any analogous thing, so Lyft has fallen further, and Lyft has been closely connected to Google, and so it is expected that Google will just buy Lyft pretty soon because it's a bargain. That is one possible way to benefit from this sort of crisis stock. As the economy crashes, it might be a good time to buy stock in some companies if you feel like gambling. Anyway, this is the Norway official coronavirus app. And the company found security flaws. Basically, this app works the way they're proposing to make the American apps work, which do not yet exist. But Apple and Google have made the API that those apps will use. And what it does is it creates a token to identify your device, and it shares it with other devices over Bluetooth. But what they did in Norway was the token never changed. So it can be used to de-anonymize you. And therefore, just having a random number that never changes is essentially what advertising cookies do. And it's been proven repeatedly that you can easily de-anonymize them. So since they don't change it every few hours, then that's a problem. So they need to switch to the one we have. At least this particular mistake is not likely to happen on iPhones or Android phones that are based on the new API that's coming out. But they may make other mistakes because the apps have not yet been written. It is quite disturbing to observe that we are still making essentially no preparations, as far as I can tell, to ever open up the economy. We do not seem to be having any success in making more testing available, either to detect infected people or to detect people with immunity or antibodies. We also do not seem to be making any progress recruiting and training a large number of people to track contacts. It is very strange. I don't know how any of us are ever going to be able to safely open up the economy if we don't make some preparations. But they are making the app, supposedly, so maybe that'll be something. So Azaria is the expert in ARM exploitation, and she just got a contract to write some books. So this will be wonderful and probably something I'll want to use in the 127 exploit development class and in 128 exploiting mobile devices. Her stuff is wonderful, and I'm really looking forward to her books coming out. That would probably be very good textbooks for classes. And ARM is increasingly important. Most of the Internet of Things runs on ARM, not x86. So here's another letter from somebody figuring out the same thing a lot of people figured out. Encrypted email is essentially impossible to use. There is the program, has existed for decades, GNU PG, that implements public key encryption for email, but the problem is when you actually try to use it, it is very, very, very painful. Everybody has tried it. I used to make the students in this class, 125, all get encrypted email working until I found out it was essentially impossible. The browser extensions don't work very well. The software doesn't work very well. It just makes you cry. And if you ever get it working, it only works until you lose your private key, which happens very quickly as you trade machines and such. So even the people that developed this system have quit using it. It is so strong that Snowden used it to leak NSA secrets out. It is very powerful if used correctly, but it is so difficult to use, almost nobody can ever use it correctly. So it sort of is the whole security trade-off in a nutshell. You can make something really secure, but only by making it impossible to use. And making it easier to use involves making it less confidential. So that's where we're at. Some hackers are claiming they have 267 million Facebook records, and I think they're claiming this is essentially all the American Facebook users. I don't know if it has been verified that this is true yet, but if it is, then, and they claim they just found them sitting on an open Elasticsearch server. So perhaps some more information will come out about this. Anyway, it's not clear whether that means everybody's Facebook account is leaked out or whether it's some kind of fake data or some kind of data from a third party or something. So I've heard about this for a couple of years. ICANN is the organization that handles domain names and IP addresses on the internet, and it is fantastically corrupt and divided against itself. There are lawsuits. It's amazing how many people are very upset about the stuff ICANN does. And so what they now wanted to do was sell the .org registry to a private company that would then sell .org domain names and make a pile of profit. And they've been blocked from the California Attorney General. This is apparently some kind of scam. A secretive buyer was going to buy it. They were going to immediately put it deeply in debt to sort of turn it into cash. And it was going to be some way of taking the value present on the internet and just turning it into money to run away and steal the money is what it sounds like. The details are still coming out, but they've been trying to do this for the last year or two, and they have not been able to do it, as various people complain greatly that it's a bad deal and they shouldn't be allowed to do it. Mayor London Breed from San Francisco appeared on Recode Decode, which I highly recommend listening to. The Recode Decode podcast is very good, and it's very good to hear her explain how she did this. She actually started preparing for coronavirus early in January, whereas the rest of the nation, the national response, didn't seem to start at all until the middle of March. And she explains what they did and how they protected us. And I think San Francisco is now a national leader, the region that by far did the best in handling this. So I think everybody wants to know how we did it and imitate us. And she even talks here about the thing that caught my attention, which is not only did San Francisco do it, but several counties around us did it all together. And it's very unusual to see people work together that well, but it's working very well. Anyway, it's a very interesting podcast to hear her explain this. And here is statistics and graphs about the 1918 flu epidemic, which is the one closest to the one we're living through now, showing how it worked. And in San Francisco, for example, they had strict social distancing back then, and then they relaxed the social distancing and had another wave of it coming back, which is, I think, what we can definitely expect, because the protests are running. Trump has announced that he thinks people should engage in protest and demand their freedom to escape the lockdowns in states. Some people have announced they're going to open this Friday or next week, even though they don't in any way have enough testing or contact tracing. So they're just asking for it to come back, and that's probably what will happen. And it also means, by the way, that it will come back here because we have internal travel. So if some states just open up and start it multiplying again, like they never really made any attempt to stop it in Florida, then they perform, then they're a source of infection for all the rest of us, but that's what you can do. So anyway, it's interesting to see what happened in the past. And there are an awful lot of interesting questions to ask about this. One of them is, what's the right scientific thing to do? And another is, what's going on with the politics that so many people are unwilling to do the right thing? Those are both very interesting questions from a viewpoint of management. All right. Anyway, so I'm going to stop this and go to the official class material. So we are here in 125. And midterm grades are out. They're in Canvas. We're down here at 420. There's only a few weeks left. Your second presentation is due in 2 weeks, although you can do it next week if you want to get extra credit for doing it early. And then comes your paper. And we're just down to the Chapter 5 lecture here, which is what I'm proposing to do. I don't see any chat messages bringing up other issues, so let's do that. And then after that, I will stop the recording and stick around for a while in case people have questions from this or any other class. And well, of course, you can ask questions during the presentation too, but anyway, that's how it's working. So this is identity and access management, which is a really big issue. You have to tell who people are, and then you have to decide what they're allowed to do. So the first thing you have to do is authentication. Now, identification is just claiming to be somebody. Authentication is somehow proving that you are that person. The easiest and cheapest and most common method is just a password, something you know, something you have, like a card you carry around, or something you are, like a fingerprint, or other ways to do it. So passwords are various types. The most common type is the static password, where the user just makes up a password and it stays the same until the user changes it. This is the cheapest and most common and weakest technique. And this is why you get all these breaches, where people find a dump of passwords somewhere, or they guess passwords, or they trick people into exposing their password, and then they get in their account. Passphrases are a lot better, where you have a whole sentence with punctuation, and this is much harder to guess than a password, where there are just dumps of password lists and people pretty much use common passwords over and over. A one-time password is another way, where you somehow are issued a password that's good only once. This is not commonly used because the distribution is a problem. The only common use of this is for a password reset. They might email you a password that will only work once for you to reset your password. And then there's dynamic passwords. You pay for a token like an RSA token, and it's got this number on it that changes every 30 seconds, and you type in that number to get in. This is fine, but it's, the tokens tend to be expensive. I think it costs about $30 each for RSA tokens. Google, you have the free versions like the Google Authenticator app that does the same thing in software. All right, and I see something on my phone. Let me see if it is a student. Nope, okay, good. All right. Sometimes I had students locked out that couldn't find the password or something. All right. So strong authentication is much better, where you have two factors, not just two things you know or two things you are, but a combination of two different factors, like something you know and something you are. And the idea here is, even if somebody's able to steal one of these, like they're able to steal your fingerprint from a glass, they can't get in because they won't also have your password, or they steal your password and they don't also have your fingerprint. So it greatly increases the difficulty of a bad guy getting in. All right. So if people are trying to guess passwords, you can tell in system logs. There are many attempts to log into the same account with different passwords. It's not a normal thing that a normal user would do. A normal user would try 2 or 3 passwords and then call the help desk or something. So account lockout is your strongest defense here, where people can only make a certain number of failed attempts before they're locked out for some period of time. And that will stop people from running scripts that just try thousands and millions of passwords. You have to have the password stored on the server somehow, so it can tell when it's correct. In the very, very old systems like MS-DOS, they would store a PWL file that just had passwords in it. That, of course, turned out to be terrible because a hacker could steal that file. So now they store a hash. So the hash is run through a one-way function, hopefully. And when they type in a password, you run it through the same one-way function and see if the hash matches. So you can tell if the password was correct, but the password is not stored anywhere, so it can't easily be stolen. Although it is in memory for some period of time, and that is another issue. So the password hashes are stored in some file, and there's often another layer of protection. In Unix, there's another layer of protection, so it's different. Only certain accounts can get at its shadow. In Microsoft, it's stored in the registry, in the SAM file, and that it can only be accessed by systems, not by other processes, by system privileges and such. So that's the game. And in Microsoft Active Directory environments, you have the password stored on the domain controller, but unfortunately, they are cached on every system they're used on, and this leads to the Microsoft pass the hash attack, which is one of the serious flaws of Microsoft systems. And this is why Microsoft has said for decades, well, back to 2000 anyway, about 20 years now, they've said a domain administrator should never log in to a laptop or an end user device. They should just execute one command with the password to avoid storing a high privilege hash on an end device. And they now have a system called siloed accounts to prevent that, but only if you have the very latest Microsoft versions. Anyway, so you can capture hashes, you can steal them from a local system if you compromise it, you can steal them from network traffic, you can read them from RAM. There's various ways to get them. They are present on the network traffic and on various devices, and then you have to crack those hashes. So the hash will look something like this. Here's Microsoft's LM hash here. So if you type in password, the LM hash is E52. And over here, if you type in password with a capital P, the LM hash is the same, because the Microsoft LM hashes that I think they inherited from IBM a long time ago isn't even case sensitive. It's extremely weak and short and very easy to crack. The NT hash was the improvement, which is a lot better. And the SHA-512, especially with many passes, is much better yet. All right, so a dictionary attack is typically what you do. You have a list of possible passwords and you just try them all until you either log into the account or you recreate the hash. So you try to prevent this by making passwords long and complicated, hoping that they won't be in the list. The brute force attack, you try all combinations of characters, which is really a large number of calculations, but you can do it pretty fast with GPUs. Rainbow tables are a trick where you would have pre-computed password hash calculations stored in a big table in memory, and then you would just look up the answers instead of calculating them again every time. So you're able to make it faster, but use up more memory. And there are various other mixtures of these attacks. Assault is a preventive measure to prevent the use of rainbow tables, where every password has a couple of random characters added to it before it's hashed. The random characters are not secret and they're stored with the hash, but the result is you can't just have one table of pre-computed passwords. You'd have to make a separate table for every value of the assault. And so it lowers the value of those rainbow table attacks. So Microsoft has had this password policy security setting for a long time. Password history and password age are used to make you change your password periodically. Then you have length. Then you have complexity requirements where it has to have 3 of uppercase, lowercase, numbers, and symbols. And then this is almost always disabled these days, storing passwords using reversible encryption. That's essentially plain text storage of passwords. And it's just there for backward compatibility with MS-DOS, which I think is not something almost anybody cares about anymore. So that's almost always disabled. These complexity requirements are notoriously ineffective. There are now dictionaries of stolen passwords that pass the complexity rule, so it doesn't really protect you very well. A more modern solution is to use Have I Been Pwned, which is an online system of all the known stolen passwords, and you can just check a password to make sure it's not on that list. It's probably a much more effective procedure than these Microsoft password rules. So users have to put their passwords somewhere, so it's a good idea to give them some kind of password manager to put them on. Otherwise, they'll have it written down and lose it, and that's an issue. All right, so something you can have a synchronous dynamic token like the RSA ID, where it's calculating these numbers every 30 seconds, and the server is also calculating them, or an asynchronous one, where when you try to log in, you connect with the server sends you a challenge, you have to type in the challenge in your token and calculate the result. A more difficult way to do the same thing and not that common. Then there's something you use something like fingerprints, facial scan, and so on. So these things, to be practical, shouldn't take too long to register a new user, just a couple minutes, and they shouldn't take too long to authenticate a recognized user, just a few seconds, hopefully. Otherwise, it's very annoying. So here's the way you rate the quality of a biometric system. The false reject rate is the extent when authorized users are rejected, and the false accept rate is when unauthorized users are accepted. So you can adjust the sensitivity of the device. If you make it more sensitive, then you'll more efficiently reject the bad guys, but you'll also start rejecting an increasing number of good guys. So to rate the quality of the system, you rate its crossover error rate. A more accurate system will have a lower amount of errors at the crossover. And you can adjust it. If you're a high security institution, you probably adjust it way over here, where you really have a high chance of rejecting the bad guys, even if you irritate a lot of good guys. If you're a more open system, you'd be over here, where you're willing to let in more bad guys in order to irritate the good guys less. Fingerprints are the most common and cheapest. And the data is not a photograph of your fingerprint. It's a mathematical representation of certain points, which is the same thing they use in court. The peaks of ridges and the branching and so on, these points are somehow stored and recorded, and that's what it's looking for in your fingerprint. You can do a retina scan where you have to stick your eye in a cup and a laser reads the back of your eye. This is what they do at the eye doctor to detect problems like a detached retina, but it's not something people like doing. Sticking their head in a holder and their eye in a cup doesn't seem very sanitary or pleasant for people. The iris scan is a lot more popular. They just take a high-resolution photo of your face. Now they can do it from 10 or 20 feet away with a high-resolution camera, and they just look at the colored part of your eye, which also has little marks and is distinctive, like a fingerprint. And this, of course, is extremely popular because of face recognition. Now that because of terrorism, they really want to put cameras in the airport that can recognize people and see if they're on a list. Although they mostly use your whole face for that, not just the retina. You can also use your hand. The geometry of your hand can be another way to authenticate you. And they can see how you type when you type in some phrase. They can see how you sign by signing with some kind of pen on a tablet. All these things are biometrics. And your voice print is the one that's been around in science fiction forever. It turns out to be very difficult to use in practice because people's voices change quite a bit as they get colds and such. Facial scan has become extremely popular these days. My phone has it. Most laptops have it. It's used extensively at airports and elsewhere. One thing I've heard is supposedly now you don't even need to get a boarding pass at some airport. They will just have a facial scan to identify you. I haven't been on a plane doing that, but whenever this coronavirus thing goes away and I get back on planes, maybe I'll see that. Anyway, it was used at the Super Bowl. And then there's your location. You can be located by the GPS in your phone or by the IP address if you're connecting, or other ways like Wi-Fi access points near you. And then a server can use your physical location to decide whether to approve or deny you. This is a common second factor for bank transactions. They can notice if you are suddenly far away from where you should be, or if you're in a country that is known for fraud. And so they can use that as a way to detect a false transaction from a less suspicious transaction. All right, so let's take a look at some Cahoots. I've got, should be here. Okay. For some reason, Kahoot started working in this browser. It never worked before. Either they improved something or I managed to fix a problem without realizing it. Anyway, I can use Brave for Cahoots now. So this is 6A, I think, or is it 5A? It is 5A, all right. 5A is here, okay. And that should be on. Well, because I haven't been using this browser, haha, okay. All right. All right. Let's see, looks like I've got 11, so in fact, I'll probably get about 8 in here. We'll see. All right, maybe 7's it. I'll give it a few more seconds. All right, 7 it is. So, what do you have to add to a password to make two-factor authentication? Okay, you can't add a PIN because that's just another thing you know. And two things you know is not two-factor because they can both get stolen together. It has to be something, a different factor, not something you know, but something about your location, for example, like an IP address. That would be a second independent factor. All right. What file contains password hashes on Unix? They're in the shadow file. Everybody knows that. They used to be in the password file in the 70s, but now it's in the shadow file. All right. How do you stop an online brute force attack? Lockout, account lockout is the best measure. All right. What's the weakest password hash system? LM, the one Microsoft used before Windows 7 in Vista, very weak and no longer used by default by any Microsoft system. All right, what biometric system would let an unauthorized person in? Okay, a high false accept rate. That's what this means. That means you let unauthorized people in. This is a high false reject rate. This would keep authorized people out. All right, so let's see who the winners are. Erica. Dude man will have to tell me who is. I want their points. And Phil. Phil's a real name, I think. All right. Dude man. Okay, good. Thank you. I see who Dude man is. Good. All right. Let's do some more of those slides then, which will be here. Okay, so. All right, so then there's the technologies to perform this access control. You typically want centralized access control. You can just have individual computers and each one of them has their own login, but that doesn't work if you have even more than a few computers or a few employees. It gets too hard. So what you want is a central place like a domain controller where all the accounts are. So once somebody is employed, you can let them on all the machines they should be using. When they're no longer employed, you can remove them and know they can't log into anything anymore, and so on. So another thing you might want is single sign-on, because typically you have many servers and many third-party services, and you'd like it so people don't have to keep logging on again with a series of different passwords to traverse all those services. And left over from the phone network is this concept of what you'd like an authentication system to do, AAA, authentication, authorization, and accountability. It should keep track of who people are. It should know what they're allowed to do and enforce that. And it should keep a log of what everybody did. And this dates back to the phone network where they would keep track of your phone calls in order to make your bill. And that's a AAA server, and you need that in any network if you're going to have any level of reasonable security, because you want to know who's been using it and what they did so you can review it later and try to find out what's gone wrong when things go wrong. Decentralized access control is the alternative where you have a different authentication system at every site. This gives your local sites more power, but it means they might be violating or not living up to your policies and so on. Attackers might get in from the weakest link. So this is very rarely used, only by very amateur systems and home users where you control all the passwords locally. Single sign-on is where you sign on once and then that authentication is somehow accepted at other systems. This is extremely convenient and commonly used, but it does mean that if someone manages to compromise a system, they've compromised many systems. So that's the balance you have to make there. So if you're going to have single sign-on, it's much better if you have two-factor authentication. But an attacker might be able to use malware or some other technique to take over a session after authentication. Then it doesn't matter how many factors of authentication you have if that happens. So users should be locking their workstations when they leave and That's one very simple form of session hijacking, which has happened to me several times. Students would walk up to me in class and use my laptop, and then they're in. Doesn't happen anymore, I think, now that, because that's one advantage of the lockdown. Anyway, so you have now your access provisioning. So you have to have some way of hiring users and having people that promote or change jobs. You give them permissions. Then you have to somehow make sure they get the permissions they need. And when they leave, you have to revoke their access rights. So there's a life cycle here. And you have to coordinate it with human resources and so on. It is an extremely common problem that someone leaves, but their privileges are not revoked promptly, and so a disgruntled employee logs in and messes up the system. So access aggregation is when you just keep adding more and more privileges as you get promoted through the company. Authorization creep is where you keep getting more and more entitlements. And this, of course, can lead to situations where you have more privileges than you should. So you can overcome separation of duties because you have the privilege of doing both jobs, which really should be two different people, and so on. So you have to audit these things. Federated identity management is a system that goes across organizations. So Microsoft has a thing called the Federated Identity Management Server. So you can log into an Active Directory domain, and that authorization and identification can be, and authentication can be accepted by another company. This is very handy, but of course it does mean that you're trusting someone else to handle the passwords. In practice, Facebook seems to be the world's identity authority. Almost everybody has a login with Facebook or login with Google option, and so you're trusting that other company. What's the difference between access aggregation and privilege creep? Access is technically we have access to more systems. Authorization is when you're authorized to do more things. I don't think there's any significant difference. They seem to be essentially the same. If you want to be pedantic about it, this is just access to systems, and this might be authorization to take actions, but I really don't think there's a significant difference. It's a good question. So Obama at one time wanted to make the federal government the centralized access provider for servers. For everyone in America, he thought that we would trust the government, a laughable concept, especially these days, and this went nowhere. In practice, everyone's happy, however, to trust Google or Facebook, which is a curious decision also, especially Facebook, that has proven over and over that they are a highly untrustworthy actor. But anyway, most people trust them to handle their accounts, whether they've considered that very carefully or not. SAML is a language used to move assertions about security over a network, like this person has logged in, this person is the administrator, and so on, so you can handle single sign-on at internet scale. So there is this cloud service called Cloud Identity, Identity as a Service. Microsoft had a thing called Microsoft Accounts. I think it's still around, where they tried to do this. This is what I say, Facebook and Twitter and Google do it, where you can log in there and they will then send a cookie over to you or a SAML assertion, which you will use to learn some things about a person. So it's a way to avoid having to manage passwords. And it's more, of course, more convenient for the user because they don't have to have another password for your service. They can just use their existing Google or Facebook account. All right. And if you were to have two-factor authentication, you might have it, but they wouldn't know or care. That would totally be up between you and Facebook to have that, and the third-party site just trusting Facebook to handle the authentication wouldn't have to bother. So you got credential management systems. These are password managers like LastPass that you might have. They typically have secure password generation and storage, and there are enterprise versions where they have a sort of domain controller system where the administrator can revoke accounts and back them up and so on. This is a pretty good idea. Everybody should be using two-factor, and you should have some kind of password manager. I switched to one years ago. You should all do it because the other system is to memorize password and use the same password on many sites, and before long somebody leaks it and then you're host. So it's very good to get in the habit of using a password manager, both for home users and for companies. So you can have third-party identity services if you want to. You can have a cloud identity, or you can run your own server, like you might buy a Microsoft Federated Identity Management Server and use that. That's one way to do it. LDAP is the Microsoft technique used to move identity information across an internal network. And there was an old version that could use plain text transmission, but now it uses secure transmission with TLS over port 389. Kerberos is a system designed at MIT to avoid sending plain text passwords over the wire. So it sends tokens that are related to passwords but do not obviously include the password. And so it's got a whole complicated system with a client is here and they're trying to connect to a Kerberos network called a realm, and they're going to do that with a ticket. And the ticket is going to be issued by a ticket granting service using a ticket granting ticket in the key distribution center. So it is pretty complicated, using a lot of encryption and a lot of pieces flying around. I think the best thing here is to just take a look at the picture rather than going through all this. So Alice wants to log in, so she goes to the key distribution center and gets a session key and a ticket granting ticket. Then she wishes to print a ticket, so she goes to the ticket granting server with her ticket granting ticket, and now she gets a service ticket, which gives her the ability to access something like a printer for a limited period of time, typically 10 hours. So it's like a ticket to a movie. You're allowed to enter, but only for a period of time, and then your ticket expires. So this is the Kerberos system. Since everything is connected to time, your clocks should be synchronized. Microsoft always makes a big deal about saying your clocks must be synchronized on your domain or the system won't work. Small time errors okay, but more than 5 minutes off might mean that people get a ticket, try to get in, and it says, no, your ticket is not in the valid time period. So there are weaknesses. The key distribution center has all the keys. There are single points of failure. If these servers are down, it doesn't work. Parts of it are subject to replay attacks. Kerberos 4 would allow one user to request a session key for another user, which they could then try to crack like a password hash. So, you know, it's been improved a bit in later versions, but there are still some weaknesses in the system. However, it is better than sending plain text passwords over the wire, and it's used all over the place. SESAME is an attempt to update it, has some features not present in Kerberos, like public key encryption, so you don't have plain text storage of symmetric keys on the server, which is a rude thing. Might be on the client too, I'm not really sure. Then there's Radius and Diameter. Radius is a common AAA server. It's so old that it has dial-in, but thinking of 56K dial-in, although it works on modern networks too. It's just a way to store credentials and have people send credentials to the server, which will then compare it to a database of trusted credentials and let you know that you're authorized to get in. Diameter is a successor, which can use TCP instead of UDP and has more desirable features, although a lot of people just continue to use Radius. TakeAx was a Cisco system that was then donated to open source. Another way to do essentially the same thing using UDP 49, and then the later version is TakeAx Plus that can have two-factor authentication and everything is encrypted, not backwards compatible, just another system to do the same thing. Anyway, you have to send passwords over the wire to use any of these systems unless you're using non-password logins like biometrics. And so the old system was password authentication protocol where you just send the password directly over the wire. And that's, of course, extremely dangerous. So the next step up is challenge handshake. The server sends you a challenge, the client adds the challenge to the password and hashes it, and then they send that over the wire. So the thing going over the wire proves that you know the password, but it's not exactly equal to the password. There were some vulnerabilities in various versions where the password hash was not strong enough, but at least it's better than sending a plain text password over the wire. So Microsoft Active Directory groups people into domains, uses Kerberos, and then you can have trustes. You can have your main company, Microsoft.com, and then you can have your branch office, which is like development.microsoft.com, and you can then say that people who log into Microsoft.com, if they're an administrator, they can go to development.microsoft.com, but they don't have administrator rights down there, and so on. You can have these trusts where an authentication for one domain is trusted in some controlled way at another domain. And you can have transitive trusts where you log into Microsoft and therefore you're trusted at LinkedIn and therefore you're trusted at some other company. Your trust percolates through many systems. Of course, there is an increasing risk with that, but an increasing convenience if those companies are really all working together closely. All right, so there's three general models for access control: discretionary, mandatory, and non-discretionary. So discretionary access control is the lowest security and the most common. This is what home laptops are. You own an object and you can do anything you want with your object. So if your company data is on your home laptop, you can email it or copy it to a thumb drive or share it with other people. The owner has full control over the access. All right, mandatory access control is the opposite, where you are in sort of a military environment where you have to have clearance and you're not allowed to access things that are top secret unless you have top secret clearance. All the users have labels, all the documents and hardware and devices all have labels, and trying to gain access to something requires a slow, expensive process of making a request for authorization to some higher body, which will then rule as to whether you are privileged enough to access that. This is what high security places like the military use. Non-discretionary access control is where you don't have discretion and you can't transfer objects to other subjects. So you can do this with roles or you can do this with task-based access control. What most companies have is role-based access control. This is what you get in a typical Microsoft domain. You sort people into groups like backup administrator and help desk technician, and then if they're in a category like network engineer, they get access to all these things. And then as people move from job to job, you just move them from one group to another. This goes in between the other two extreme models, discretionary and mandatory, and gets a medium level of security that is practical enough for most business situations. Another way to do it is with task-based access control, where you are given a job and you're given certain privileges tied to your job, not really tied to the person. All right. So I should say Tate, by the way. All right. Anyway. All right. And then there's rule-based access control, where there's just a series of rules. Like firewalls have rules. If the port number is this, accept it. If the port number is that, reject it. And you can just have a series of rules. If the location is okay, do it. If the time of day is okay, let them in. That sort of thing. So you can have content and context dependent controls added to others. Like beyond identification and authorization, you might have other rules. Like horizontal rules, you could, even though you're authorized to see employee data, you're only authorized to see your own data, but not other people's data, or that you can only access it at certain times of day or from certain locations. So these are other layers of access control beyond just proving who you are. In the military, they call the main one vertical authorization, what level you have, and the horizontal one is need to know, where even though you're cleared for top secret, you're only cleared for top secret in this country, and you don't have a need to know what's happening in the other country, so you can't see that stuff. So there are two layers of control, and that's similar to what you have here. So let's do another Kahoot. Is 5B. Good, it's remembering that. Okay. There were 7 last times. So I'll see if we get up to 7. I remember that guy from the really old Superman comics. I think his name was even longer, though. All right, I'll give it a few more seconds. I think we may have lost one Kahooter. All right. So, what system accepts an identity from a different organization? Federated identity management. Single sign-on just accepts it from a different server, usually in the same company. Federated identity management is where you actually accept some other company's assertion that you know who this person is. What system runs on UDP 389? That's it. LDAP, Lightweight Directory Access Protocol, used in Microsoft Active Directory. What's a TGT lifetime? That's the ticket granting ticket, good for 10 hours. And by the way, if you hear talks by the guy that wrote Mimikatz, what he likes to steal is the golden ticket. The golden ticket is the root of trust of an entire Kerberos system, and it lasts for 25 years. And if you steal that, which he can do, then you have totally compromised the domain until they rebuild the whole thing. It's bloody awesome. Anyway. All right. So what's the European improvement on Kerberos? That's SESAME. I've never used it. I always used Microsoft Kerberos, but anyway, there must be something that uses SESAME. I don't know of any product. Probably something open source anyway. I don't know. All right, what access control model do you have on your home laptop? Discretionary access control. The owner can do anything they want. They do not have to ask anybody for permission. All right. So Dude Man wins again. And that guy, I'm betting, is probably Ed. And Erica. All right. So if that's not Ed, let me know. It is Ed. That's what I thought. Good. There's a pattern to Ed's names. I'm pretty good at guessing them these days. All right. So I'm going to stop the recording and